Weather 5.1 Heat and temperature. Let's explore the intricate dynamics of heat and temperature, two fundamental variables that play a crucial role in describing the state of the atmosphere, with particular significance in aviation and weather phenomena. Temperature variation. Air temperature is a fundamental variable that undergoes continuous changes. These changes occur over seasons, between day and night, and even within shorter time frames. Additionally, temperature variations exist across different locations, altitudes, and latitudes, influencing various aspects of flight operations. Foundation concepts. Matter. Matter constitutes the substance of all physical objects, comprising atoms and molecules with mass and occupying space. The Earth's gravity imparts weight to matter. Energy. Energy represents the capacity to perform work and can manifest in various forms, undergoing conversions. Kinetic energy, associated with motion, is present in atoms, molecules, and physical objects. Heat. Heat is the collective kinetic energy of atoms and molecules within a substance. There exists a range of kinetic energy among atoms and molecules due to variations in motion. Temperature. Temperature is a numerical representation of the average kinetic energy of atoms and molecules in matter. It directly correlates with the energy of molecular motion. Higher temperatures signify increased kinetic energy and faster molecular speeds, while lower temperatures indicate reduced kinetic energy and slower molecular speeds. Temperature serves as an indicator of the internal energy of air. Temperature measurement. Thermometers gauge temperature, with higher readings corresponding to greater molecular energies. Temperature scales. Kelvin scale. A thermodynamic temperature scale with absolute zero at 0 K, signifying the theoretical absence of all thermal energy. Directly measures the average kinetic molecular activity. No negative numbers exist in the Kelvin scale. Celsius scale. Widely used globally and in meteorology, based on the freezing, 0 degrees C, and boiling, 100 degrees C, points of water under standard atmospheric pressure. Each degree on the Celsius scale equals a degree on the Kelvin scale. Adopted in aviation weather reports. Fahrenheit scale. Utilized for everyday temperature measurements in the United States. Freezing point of water is 32 degrees Fahrenheit, and boiling point is 212 degree F. Conversion software is often used to present METAR temperatures in degrees Fahrenheit. Heat and temperature relationship. Thermometer readings change with heat addition or subtraction. While heat and temperature are distinct, they share a close relationship, influencing various aspects of atmospheric conditions and aviation operations. Heat transfer. Heat transfer dynamics. Heat transfer, the process of energy transfer resulting from temperature differences, occurs when a physical body, such as an object or fluid, possesses a temperature distinct from its surroundings. This leads to thermal equilibrium, wherein the body and surroundings reach a balance. It's essential to note that heat transfer always transpires from a hot body to a cold one. While it cannot be halted, it can be slowed down in the presence of temperature disparities. Solar influence. The primary heat source for Earth is the Sun. Energy from the Sun traverses space in the Earth's atmosphere to reach the surface, contributing to the warming of the atmosphere. Three modes of heat transfer: radiation, conduction, and convection, either individually or in combination, play pivotal roles in this energy exchange. Radiation. Radiation overview. Radiation is the transmission of heat energy through space via electromagnetic waves. Unlike conduction and convection, it doesn't rely on a medium for transfer. Objects emit energy as heat, which travels through air, water, or space. This radiant energy can be reflected, absorbed, and converted into heat energy by objects it encounters. Solar and terrestrial radiation. Both the Sun, solar radiation, and the Earth, terrestrial radiation, emit radiation energy. The wavelength of maximum radiation inversely correlates with temperature. Solar radiation reaching Earth's surface varies with solar zenith angle, affecting insolation, incoming solar radiation. Dark-colored objects absorb and radiate energy more efficiently than light-colored ones. Conduction. Conduction involves the transfer of energy, including heat, through molecular activity between substances in contact or through a substance. It occurs from warmer to colder substances, with the rate influenced by temperature differences and the material's heat conductivity. Materials with higher thermal conductivity facilitate faster heat transfer. Air, being a poor thermal conductor, exhibits limited conduction. Thermal response. Specific heat capacity. Specific heat capacity, measured in joules per gram Kelvin, JG1K1, gauges the amount of heat energy needed to raise the temperature of a unit quantity of a substance by a certain interval. Water boasts the highest specific heat capacity among naturally occurring substances, enabling it to store significant heat energy with minimal temperature change. This property contributes to the thermal inertia of water bodies, leading to slower temperature variations compared to land surfaces. Temperature moderation. The disparity in specific heat capacities explains why water bodies, such as lakes or oceans, exhibit more gradual temperature changes than land surfaces. Water's ability to circulate heat energy through convection and its resistance to temperature alterations contribute to its moderating effect on nearby air temperature. Consequently, maritime locations near water bodies display smaller diurnal and seasonal temperature variations than continental locations located farther inland. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.